Good afternoon. Welcome back to Algebraic Connections. Today we're going to discuss finding the zeros of polynomials. First, let's discover what are the zeros of polynomials. The zeros of polynomials, or you could call them roots also, are the value or values that cause polynomials to equal zero. If we're talking graphically, it is the x-intercept. That value, the root is the x value and the zero is the y value. So let's get some review. Going back to Algebra 1. Factoring trinomials, because this will assist us in finding the roots or zeros for polynomials. All right, to factor a trinomial, tri meaning three terms, you find the factors of c that will add to give us b. So here our c term is negative 42. We always take the sign that goes with it. What are two factors of negative 42 or 42 that will add to give us negative 1? Okay, so 6 times 7 is 42, but we have to get negative 42. So one of those values have to be a negative. Well, in order for them to add to get negative 1, the larger value must be a negative. So we can just write x and x here because we know x times x is x squared. And since this is positive, we can put a plus sign. If we were to go back to multiplying these two binomials, the end result would be this trinomial that we started with. Another example, you go through trinomial three terms. In this case, there's a GCF, or greatest common factor. Notice all of these terms, 2 can divide evenly into all three of these terms. 2 divides evenly here, leaving us with just 1, or w to the second power. We could divide 2 into 20, leaving us with 10. And we can divide 50 by 2, leaving us with 25. Now we go through the same process of finding two numbers that multiply to give us c, add to give us b. Those two numbers are 5 and 5. So that becomes w plus 5 and w plus 5, bringing our 2 down. And since we have the same thing twice, we can rewrite that as w plus 5 to the second power. And bringing that 2 down. So that's reviewing trinomials. What if we needed to solve an equation? We will subtract 15x from both sides because we need to get 0 on a side by itself. So here we have x to the third power plus 2x to the second power minus 15x to the second power. And notice this is a trinomial, three terms. There is a greatest common factor. There's a GCF in all three of those terms. The common factor is x. So if we factor out an x, that leaves us with x. We take an x away, that's x to the second. That leaves us with 2x. And that leaves us with negative 15. Let me go back and correct this. This should be just negative 15. So here's our trinomial again. Two terms that multiply to give us negative 15, add to give us 2. 15. 1 times 15 is 15. 3 times 5 is 15. Because it's negative, one of the values will have to be a negative. So we keep that x, bring it down. 2 numbers to multiply give us negative 15 and add to give us 2. Multiply to give us negative 15 and add to give us 2. So if I was to write that to the side, 5, negative 3, negative 5, 3. If I add these terms, that's 2 and that's negative 2. So I need to use 5 and negative 3. 5, negative 3. So the trinomial factor to x times x plus 5 times x minus 3. Now we have to solve each one using the zero product property. So we take x, set it equal to 0. Take x plus 5, set it equal to 0. X minus 3, set it equal to 0. That's already 0. X equals 0. Here, to get x by itself, you subtract 5 from both sides, and x will equal negative 5. So x equals negative 5. X minus 3 equals 0. You need to add 3 to both sides, so x will equal 3. So notice we have 3 values for x. What does that mean? That means the solutions are the zeros for this equation. Those 3 solutions, 0, negative 5, and 3 are the zeros. How are they the zeros? Because these are what make the value of the equation 0. One way to find zeros of polynomials is using synthetic division. So here we have a 4-term polynomial, x to the third power plus x to the second power minus 22x minus 10, and we want to divide it by x plus 5. You can only use synthetic division when dividing by a linear term, meaning the term that you're dividing by is x and not x to the second, x to the third, x to the fourth, only x minus something or x plus something. If dividing by the factor x plus 5, you start by finding the 0 associated with this factor. That goes back to similar to what we just did. So negative 5 makes this 0. Negative 5 makes that 0. So we have our negative 5. Synthetic division involves only the coefficients of the dividend. So let's look at our coefficients. When you don't see a coefficient, it's understood to be 1. Same here, understood to be 1. This coefficient here is negative 22. And this constant is its own coefficient, negative 10. So now the process in doing synthetic division is you bring the first term down. So this is 1. You multiply the term here by your dividend. Negative 5 times 1 is negative 5. And we add 1 plus negative 5 is negative 4. Same situation. Negative 4 times negative 5. That gives us 20. Add, that's negative 2. Negative 2 times negative 5 is positive 10. Add, and that is 0. Notice that this last column here is where your remainder is located. There is no remainder when you divide this. So based off of these numbers here, 1, negative 4, negative 2, those would be the coefficients for your new polynomial. So it would be x to the second minus 4x minus 2. Your exponent is always 1 smaller than the larger power from when you started dividing. Let's look at this example. All right, we first find the 0. X minus 2 equals 0, so 2 is the 0 for this term. Then we go find the coefficients of each one of these terms. So this is understood to be 1. This is understood to be -8. This is 37 and -50. Bring the first term down. It's 1. 1 times 2 is 2. So you always multiply and make sure you bring it here. -8 plus 2, -6 times 2, -12. Add these. 37 plus -12 is 25. Times 2 is 50. And this is 0, which means my remainder is 0. So my solution for this expression, x squared minus 6x plus 25 is what we get. Give you a little time to get this down if you're copying at home. Okay. What if a term is missing? If any terms are missing in the original polynomial, they must be filled in with zeros before using synthetic division. Well, we know we find the 0 here. The 0 for this is -4. So we have x to the third power. Do we have x to the second power? There is no x to the second power. We have x and we have our constant. So x to the third power is 1. Because we don't have anything to the second power, that coefficient is understood to be 0. When you don't see it, there's nothing there. 0. Our linear term, -13, or the x to the first power, -13, and our constant is 12. Bring this first term down. Multiply 1 and -4, that gives us -4. Add those terms. Multiply -4 by this -4, that gives us 16. Add these, -13 plus 16 is 3. 3 times -4 is -12. Once again, my remainder is 0. These are my favorite kind when the remainders are 0. So my solution would be x squared minus 4x plus 3. All right, we have 2x to the fourth plus 6x to the third plus 5x to the second minus 45 divided by x plus 3. My 0 for my linear expression x plus 3 is -3. So let's go through all my powers. 2x to the fourth power. 6x to the third power. 5x to the second power. There is no x to the first power, so it's understood to be 0. And negative 45. Bring my 2 down. Multiply. Negative 3 times 2 is negative 6. Add this column a 0. 0 times negative 3 is 0. Add this column, that's 5. Times negative 3 is negative 15. Add this column, that's negative 15. Negative 15 times negative 3 is 45. So the remainder is 0. Now here's interesting. Once you have a 0, that lets you know that's a term you don't have to list. So we started with x to the 4th power. 1 less than the 4th power is the 3rd power. So this becomes 2x to the 3rd power. We don't have to do 0. So this 3rd power, 2nd power, this will be 1st power. So this is 5x minus 15. Once again, your power of what you get will be 1 less than what you started with. Rational root theorem. To find the possible rational roots, you want to take the values of p and the values of q and create a ratio of p to q. All of your possible rational roots, p to q, where q are the factors of your leading term and p factors of your last term. So the factors of p, that is 1 times 26 and 2 times 13. Positive and negative. Listen to all the positive and negative values. Possible values of q, the factors of q, just 1 and 2. Once again, the leading term is q. The factors of q, 1 times 2, positive or negative. The factors of p, the last term, constant term, 1 times 26, 2 times 13 gives us 26, positive and negative all the way across. So these are the possible rational roots for this function. So say list the possible rational zeros of f using the rational root theorem. Looking back at what we just did, you take all of these. This becomes 1, 1 over 1, 2 over 1, and that's plus or minus. 13 over 1, 26 over 1, 1 over 2, plus or minus 1/2. Yes, we will have fractions from time to time. 2 over 2 is already there, which reduces to 1. 13 over 2, plus or minus 13/2, and 26 over 2, which is already here. So back to this one. The rational roots, the rational zeros, my factors of q, which is my leading term, plus or minus 1, plus or minus 2. My factors of p, which is my last term, or my constant term, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The reason again is plus or minus, meaning it could be positive or negative. So the possible rational zeros would be P over Q all of these divided by 1, so they would be themselves. Positive plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All these values over 2, plus or minus 1/2, plus or minus, okay, 2 over 2 reduces to 1. 3 over 2 plus or minus 3/2. 6 over 2 reduces to 3. So these are all the possible rational zeros using the rational root theorem. So now, to determine the zeros, we go back to having a zero as a remainder. Having a zero as a remainder. We had a lot of examples of having zeros as remainders. To find all the zeros of this function. Now, here are our possible rational roots. These are our possible rational roots. We have to go through each one of these to determine what are our zeros. This 3 is highlighted to let us know that you will have 3 zeros. Whatever your higher exponent is, or whatever the power of the value is, that's how many zeros you will have. So, plus or minus 1. Let's go through it trying 1. Bring the 2 down. 2 times 1 is 2. Add these. 3 plus 2 is 5. 5 times 1 is 5. Add these. Negative 11 plus 5 is negative 6. Negative 6 times 1 is negative 6. Is this a 0? We add these, this would be negative 12. So with that being said, 1 is not a root. What about negative 1? Negative 1, bring 2 down. 2 times negative 1. Add these. 1 times negative 1. Let's add them. Negative 12 times negative 1 is 12. This is not 0. So we go through the list of all of our rational root possibilities to determine what the zeros are. Keep in mind, there are 3 possibilities, and there are 3. If you think you know those 3, you could possibly win a gift card. You can hit me up on social media, Twitter at CoachDJ2, Instagram at d.july2, Twitter at CoachDJ2, Instagram at d.july2. I'm gonna let you see that again, heading out. And see if somebody wants this Food Sackless gift card. And see y'all next week.